Welcome all to our second season of podcasts with our very own three data wise guys as we continue to address the real question Virginia wanted to ask Santa Claus. Why is data management still important? I'm Barb Richards, the product owner for Quorum Software's Energy IQ suite of data management focused products. Matt Becker, who is the managing director of data management at Solexis, and I co-chair the PPDM Association's Education Advisory Committee, and we are the plus one you will hear hosting these podcasts. Our esteemed wise guys are returning for another season, and I'd like to welcome back Jim Crompton, currently a consultant and professor at the Colorado School of Mines with 37 years at Chevron, John Jacobs, a consultant who brings 40 years of experience in both the services and operator side of the oil and gas industry with 20 years at Anadarko, and Tim Coburn, currently a consultant and professor at Colorado State University, who draws on his 40 years at operators, including Marathon and ConocoPhillips, government and research organizations, including the National Renewable Energy Laboratory. We've taken to heart your feedback from our first season of 6 podcasts and are inviting guest speakers from the data management community to join us this season. We look forward to lots of shorter conversations with industry leaders talking about challenges, discoveries, and new directions. To keynote this season, I have the great pleasure to introduce Trudy Curtis, CEO of the PPDM Association for the last 26 years, to offer her insight into PPDM and the shifting landscape. Trudy has led decades of international work to define, refine, and grow the data management discipline in the global energy industry, beginning in the petroleum industry and now expanding the development of solid data management practices into diverse energy domains. Welcome, Trudy.
Thank you, Barb. I'm glad to be here.
Good. You've been at this for a while now, 26 years. And before that, right? How have the perspectives that you have perhaps held in the beginning changed over the years?
Well, they've changed quite a bit, Barb. When I first began in data management, even before I joined PPDM, every focus on data management was really about technology. And when I joined PPDM, the standards were all about building the perfect container, at that time, a relational data container. And there was a prevailing belief that if we could just create the perfect relational container for data, that all of our data problems would just magically go away because the container would solve all of that problem. And that prevailing belief has continued even now, that many people do believe that the right container, the right technology is going to fix their data. What I'm seeing today is in part a continuation of that belief that we're still trying to solve our data problems with container, even though decades after we began doing this, time has proved that we can't actually solve our data. If we could solve our problems with technology, we would have already solved our data problems years ago. And we haven't, because technology isn't what solves the problems. What we have changed, though, is our understanding and belief that the way that we store our data, our particular technology, our particular methodologies, are our competitive advantage, that our vocabularies are our competitive advantage, and that the methods that we use to store data are our competitive advantages. We've begun to understand that those are not a competitive advantage, because we know that of all the data that any energy company receives, most of it comes from outside sources, all of whom are managing the data in the way that makes the most sense to them. And it is the diversity of those practices that causes the data dissonance that makes us have to solve data problems again and again and again.
I love that term, data dissonance. I think that describes many of our daily lives. Those of us in data management struggle with that. So we still have problems, is what you're saying. We haven't fixed everything by having the relational data set out there.
We haven't. We fixed something. And large companies with lots of capability, yes, they can enforce a level of control on their data. But the fact that we are not all on the same page with regards to our data is continuing to cause a lot of data dissonance.
All right, wise guys, where do you sit on data dissonance?
Well, Trudy, this is Jim. Welcome to the second season.
Thank you.
I mean, you're truly an icon and an evangelist for a lot of us. We had a discussion in season 1 about the technology changing and it being the, the shiny new toy that we all kind of grab to. But I think I totally agree with you. I mean, if the container, we've actually called data management technologies containers now with Docker and other kinds of things. But, if we totally agree, if that was the solution, Edgar Codd would have had the answer right back at IBM with the SQL relational technology things. And obviously he's come and gone, and the data issues are still there. I think one of the things that Virginia, why she asked Santa Claus these questions is the fact that it seems that once we maybe wrangle one type of data to the ground and figure out how to manage it, there's another type of data that pops up, and all of a sudden it becomes important to how we try to solve our problem. I was just going to ask, given PPDM's recent kind of name change, I guess, if you will, or whatever, and acknowledgement that more data in the energy space is also under the important scope. Can you talk a little bit about how you're seeing the kind of the growth in the amount of the types of data that we become interested in, all the way from early days in subsurface geological, what is a well, kind of information, now to, there's so much more that seems to be relevant.
I think you're absolutely right. We see a lot of changes in companies who want to do better, become more efficient, to become environmentally sustainable, to be transparent in terms of their governance. They want to cover more of the life cycle of data. Back in the day when I was a youngster in data management, we could manage little bits of data in silos. And that data tended to be as it pertained to operations that were underway right now. It's real-time data to solve real problems. And I don't mean real-time in streaming data, but the data that happens during the construction or operation phase of an asset. But it's just as important for us to understand what's happening during the planning stage of an asset's life cycle, and to have a good understanding of what happens during the disposal of an asset. That's particularly when a lot of our environmental and regulatory restrictions come into play, and we have done a poor job. So we're now covering a lot more of the life cycle, and that means a lot more data. We have to understand what we wanted to do, what we planned to do, what actually happened, how did we react when bad things happened, and what did we change? Was that effective? All of those questions can now go into analytics tools to help us to predict how to do operations more quickly, how to do predictive maintenance. We're also seeing a lot of enthusiasm for the IIoT, the Industrial Internet of Things, and these little tiny devices that are being placed in the wellbore. They're being placed on windmills. They're being placed in solar generators. They're being placed in human beings. And that data is being generated at a tremendous rate, but industry is only using a tiny, tiny fraction of those devices. And this is something that we're going to see happening more and more. The amount of data, the variety of data, the speed with which that data comes is only going to resolve. And that means that we have to have some foundational problems to make sure that that data is born in good shape and stays in good shape through its whole life cycle, because we will not have time to go through and keep fixing that data again and again and again, or changing it again and again to meet our particular needs. I think that means that the me-centric time of data management is at an end. And we must arrive at a we-centric method of data management, understanding the totality of data management needs and data needs through the life cycle of that data, and make sure that it's positioned to meet everybody's needs all the time, instead of continually adjusting it selfishly to do what I want it to do, because that's what causes the dissonance, and that's what's causing us all the delays, all the problems, all the confusions.
Trudy, this is Tim. I want to go back to this idea of the container you mentioned from this context of data dissonance. And I don't want to name names here, but just day before yesterday, a very large petroleum services company that we all know and is dear to our hearts announced that they had signed a large contract with a big company to basically do exactly what you said, dump all their data into a big container. And I may be misrepresenting the idea here, but that it came across as we're going to hire this large company to come in and take care of all of our data. And I think this philosophy continues to persist, as you've already said, at the higher up corporate level. I think an idea goes kind of up the ladder, and people kind of grab that idea and gets people excited, and without thinking about what they're really doing, they go out and buy something and try to dump numbers and information into it in hopes that that's going to solve the problem. I just think this is going to continue. I don't know how to, I've been doing this for a long time. I don't know how to get around it, but it continues to manifest itself over and over again.
It's a really tough problem. Technology is cool. It's tangible.
Mm-hmm.
You can write a
Yep.
check for 6 or 7 figures and get something that people can install on their computers and they can actually do stuff with. Data is much more intangible. But what we have to remember is that technology is very transient. By its nature, it's transient. And particularly today, the kinds of technology, the kinds of containers we're using are evolving very, very swiftly. If our data practices depend on technology, we have to assume that that data has to survive the changes of technology, potentially many times over its life cycle, because data must persist as an asset for many years, many times for decades. And how we get data to survive that transition from technology to technology to technology over periods of days or decades when our focus is on the technology and not the data. And we're surprised that our data tends to attenuate. We lose data context. We do the most appalling things to data in the interest of stuffing it into some cool new technology so we can push those shiny buttons and generate exactly the right kind of graph that's going to make our manager drool, when that damage that's done to the data is often irreversible. We need to start focusing on making the life of data survivable. Data tends not to survive these technology changes, and that's a tragedy.
I think you're speaking to the choir here.
I guess talking about this in terms of PPDM and what the transition that PPDM is going through right now, we've learned a lot. Even from what you've discussed this morning, we've learned a lot over the last 30 years of PPDM. How do we take that into the next chapter of PPDM, into the broader energy industry? I mean, there's a lot of them that probably today don't even know what data they should be preserving, let alone how to manage it. So how does PPDM help that, broader energy industry make those types of decisions and changes?
Well, that's a good question. And if I knew the answer, maybe we would have fixed it already. Here's in a company, whenever you want to talk about data, and you begin a conversation talking about data, in 2 or 3 minutes, technology strolls into the room, makes itself comfortable, sits back, and then without any effort just takes over the agenda. Before you know it, it's a talk about technology, and it's not a talk about data. And if data sticks up its head and says, look, we don't know whether or not our data problems are going to solve with this technology. Technology says, don't worry about it. We'll solve all of those problems for you. We've got just exactly the right container to do what you want to do. And management loves that message. They really want to buy technology. They really want the problem with their data to be fixed. The trouble with data is that it's an intangible asset in many senses, and we have to keep changing it. I don't always say fixing it, although unfortunately we do end up fixing it again and again, and management has just lost patience with that. And so this idea that we have to change our vocabularies, change what we store, drop data out of a container, make it proprietary, all the things that we do to data, that has to stop. And we have to learn how to make it stop. So that data, as that stream that flows through the whole life cycle of engineering and geosciences and procurement and AFEs and all of those things, that data has to flow through smoothly without being damaged or broken, without snagging on broken branches or anything like that. And that will take an industry-based, focused mindset on the data so that it can survive technology and thrive in an environment where we can leverage the technology that we want that will do what we need it to do. There's not just JSON, there's graph databases, there's not only SQL, there are things that are tuned to real-time data, there are things that are tuned towards analytics. We need to be able to move our data around in this environment with tremendous flexibility. And that is really important. It depends on us treating the data as the asset.
Well, I couldn't agree more with that, Trudy. I think that's exactly the area that we've talked about for the last series, was about treating data as an asset. And I think one of the aspects of this is the people that are involved in this, and that they have to be trained and they have to be knowledgeable enough in the data they're dealing with to be able to foresee and handle a lot of the issues we're trying to get around or to solve. So how do we educate the broad energy industry that, it's not the technology, it's how we use the technology and the people that are involved in that.
I think we have to think about what it means for something to be an asset. And it's simple economics. An asset is only an asset if you can prove that it's an asset. You have to be able to document that. And by definition, if data is not an asset, you cannot prove that it's an asset. It is by definition a liability with potential risks associated with it. And we tend not to think of our data in that balance sheet kind of a way, in terms of whether or not data is an asset just to me, but to everybody. And I think that's what we have to think about. Maybe we need to get right down to the economics, to the nuts and bolts of the data, and think about what it takes to maximize the asset value of data to everybody. Because the data is highly mobile asset in the energy industry. And we have to make sure that it remains an asset for everybody in the industry, not just a particular user group. We learned this data agile process and fit for purpose years ago. And those two things, agility and fit for purpose, are really good in the software world, but they're not good in the data world. In the data, we need to think more about data as an asset that has to be managed like we manage all of our other financial assets, rigorously, consistently, to ensure that we're proving and maintaining the value of that asset over a long period of time.
I was going to say this is a problem that's not unique to us in oil and gas. And as an example, last night I was actually teaching a class in a course that's called Transitions in Energy Systems, and I was on the power sector last night. I invited three outside guests, 3 industry guests, and my intent was to talk about data. And what happened? They immediately went to technology. And trying to think about software solutions and hardware solutions, and that was the discussion that they wanted to talk about, not about the data. And it's sort of endemic across all kinds of business sectors.
It is. We don't have a data-centric culture in any industry. We have a technology-centric culture, and that is an unfortunate problem. And I see it persisted everywhere. I see it in schools. I see it in the boardroom. I see it in classes where people say, "Can't we? When I'm learning about data, can't we learn it into a piece of software so I can work on it with this piece of software?" But that's not what we're trying to do. We're trying to teach people about data. But that desire for technology is so strong. It's difficult to overcome. And it's there. It's important. Technology is important. We can't get that wrong. But it's not the same thing as data.
Yeah, that's correct. And we have to keep saying that.
It seems there's some really key lessons here that Santa is teaching Virginia as our future data management expert as we go through that. One, data is an asset. And I think you've made a great point about that. Two, that it's not just a technology. As a professor, along with Dr. Coburn, I also acknowledge technology is easier to teach than data. If you're putting yourself into a class with new students and the rest of it, I think we all know how to teach. I mean, I can't believe it, but I'm teaching Python programming. I'm building artificial neural nets to how to solve a preventive maintenance problem on an artificial lift unit. I mean, that's insane for a petroleum engineer. But I want to build on just a couple of your points here on my last question. But you made a great point that I'm going to try to remember, that data has to survive the technology changes. And maybe we need a UN convention on the prevention of cruelty to data from all of these technology transitions that we use. And then we can write up some of these new high-tech companies, and we can get them to pay up here. I was in just like Tim yesterday with his class, I was in a meeting yesterday. It was that really demonstrated what you're talking about, maybe in a allied related field, but it's about environmental sustainability and stewardship of oil and gas. And the regulators are now weighing in more heavily, and it differs by province and state and federal and country and UN and everything else like that. Unfortunately, there's a patchwork of kind of expectations on the industry, but it was getting all around to this idea of data. You know, measurement informed inventories was the theme of the meeting that I was in. And again, but I mean, that's a good thing that we believe that data is actually going to help us with our estimates of emissions. So that's going to lead us in the right direction. And I think that's very true. But once again, there was this idea of what is a container? Well, the container in this world is something called this greenhouse gas inventory. That the idea was introduced by the US Environmental Protection Agency in the 1990s, which really is just a spreadsheet combination of a bunch of engineering factor estimates of what we're doing. And now we want to improve that estimate based on data. So we now have this new container, which is just a fancy spreadsheet. We're now trying to figure out how we're going to stuff data. And the conversation, as Tim was talking about, goes to, well, what kind of fancy new air quality technology? You use satellites, you use aircraft, are you going to use LIDAR, are you going to use continuous monitoring, OGC? I mean, there's a whole world of acronyms that spout, from these conversations. And in the end, I mean, Virginia's got to learn that it's down to data, understanding the data. And actually, from all these new technologies, the data isn't the data. I mean, it's all related to the same problem, the operational efficiency, but understanding the vocabulary. I won't go into the details, but geospatial and temporal and probabilities and uncertainty. I mean, all of a sudden you have to go back to your sophomore level statistics class, which all of us didn't like very much and probably didn't get a very good grade in, and have quickly forgotten almost everything we tried to learn there. But that's now highly relevant. So data isn't a point. It's a probability distribution. It's a series of stuff over there. How to, and again, I think it's experience more than the classroom teaches this, that one of the things Santa has to tell Virginia is get a good job and really focus on this for a while, because it's not simple. Kind of in your maybe summary of all of this, what does Santa say to Virginia so that she can be successful?
Well, I can start by saying ho, ho, ho. Let me tell you what we're doing at PPDM that we think is going to really help. And if we can wrap this up in a way that people can understand, we may ultimately be successful. So we take we take data containers and data communication protocols out of the equation at PPDM. And we think about what is it that causes data to go wrong, other than breaking it when you stuff it into the wrong kind of container. And there are several things. We've identified 6 ecozones within that data ecosystem where data tends to go wrong, starting with people mean well, but they don't know any better. And talking about issues that we have with identity and version management, problems that we have with vocabularies, all of those kinds of things we talk about at PPDM. And we are now designing data objects for industry that are very intentionally technology neutral. They only talk about the data. If I have one of these pieces of data, what needs to be in it? What does it look like? What do we call it? How does it behave? How do we know if it's any good? If there's something wrong with it, what should we do about it? And we're working with a number of volunteer work groups at PPDM on several different aspects of this problem, and it's coming together really well. But even for data professionals, we have to let go of our passion for technology. People say, well, I could just put it in a spreadsheet. What if you don't have a spreadsheet? So I think helping people to understand and separate the data from the technology is really important. And then we need to show people how data really is interesting, how it really is exciting, how it is something that you can base your career on. And once you get that into good shape, the astonishing things that you can do with that data using analytics or intelligence tools or decision support tools or even basic interpretation tools, and the flexibility that you have to move data as an asset from one technology asset to another technology asset without breaking the bond between the two of those things. Data is an asset and technology is an asset, but they're not the same asset. I think that's what we have to teach people. And I think the work that we're doing at PPDM to show people how data behaves when there's no technology in the equation at all is really important and very helpful. It's something that our industry players that we're working with are really excited about.
We need to give Virginia a technology detox program there before she moves forward.
Well, it's not just a detox problem. They may have to go into rehab for a while.
So this is an interesting shift now that we are now actually trying to educate our industry on the correct ways to collect data, the importance of collecting that data. We may not be able to have all the answers and what to do with it right now, but at least we are pulling resources and effort onto the process of collecting data well and wisely, so that future generations can extract value from it. That's an incredible shift from where we once were.
That makes a lot of sense. And to have strategies about data and strategies about technology that talk to each other but aren't the same thing. Data governance strategies and data mastering strategies and data management strategies, those 3 strategy programs need to be developed independent of technology. The tactical execution of your strategies may involve technology, but your strategies should never be technology focused. Technology isn't long lived enough for that to happen, for data to work well. We have to base our data strategies on the asset that's going to live for decades, not on technology that's going to be replaced. Today's technology is JSON and Python. How long will it be before those technologies are replaced? We have to be agile. And
They'll be the COBOL of tomorrow.
Yes.
So this has been an incredible shift already. Trudy, where do you see PPDM shifting to next? Think 10 years, 20 years from now.
Well, I have a dream, and in my dream, technology is on a beach in the Caribbean with a fizzy drink, one of those little umbrellas in it, because all of our work has been done. But realistically, I don't think that that's going to happen. Where I think PPDM needs to play the most important role is not only in this separating data as an asset from technology. It should not be a slave to technology. We need to build a data-centric culture that focuses on the needs of data as an asset that has to flow seamlessly between departments, between organizations, between companies, between industry and regulators, between industry and the public and research institution. It has to be able to do that as a healthy, well-formed data asset and not something that has been stuffed into a technology. We need to really build that data culture so that people think about data not in terms of what I need, but in terms of what we need. The holistic approach, the same as we did in the safety culture that we built years ago in our industry, we need exactly the same culture about data in our industry. And that, I think, is what PPDM will be able to help us with, to think about data as our asset.
Trudy, this is Tim. I'm struggling a bit. You and I and John and Jim have been doing this for a long time. And I think we're all struggling with how to operationalize exactly what you just got to saying. We want to leave a legacy of having kind of addressed this and gotten people on board. But as we move along, it just seems to be getting a little worse. And we're going backwards and going forward. Do you have any advice, counsel? I mean, can the three of us, four of us, kind of think of some ways to move forward that would really interest younger folks, grab them a little bit, get them going, make them understand the importance of what this is all about, rather than just saying the words to them? Get my drift there?
That's a really good point, Tim. People are addicted to technology, and our young people are more addicted than the old folks. And the need to bring technology into everything that we do is really high. And we're only feeding it by teaching technology to our young people when they're at school. We're teaching them data is about technology. The separation of those two needs to be a very conscious thing. And I think that can be done with well-formed teaching classes, with information that focuses only on the data and only on those data objects and what it is that they look like, including experiences in taking that data. You know, if I was going to design a class, I would show people how a particular data object needs to behave, what needs to be in it, what are the attributes, all those kinds of things. Then I'd have them take that same data object and stuff it into a spreadsheet, stuff it into a relational database, stuff it into JSON, stuff it into a graph database, and compare and contrast the differences in what happens to that data as you move it in technology. Compare where you started with and what you've got after you put it in these different technologies, and allow them to experience those changes for themselves. So what we need to do, really, I think, is show them that that what they do with the data in technology can help data, or it can damage it. And if it does that, if we need to put data in a technology so that it damages data in some way, we need to do that consciously and think up at the strategic level about how we're going to protect that data that's not going into that particular container, but might be needed to go in another container. And I think we can teach kids how to do that.
I couldn't agree with you more. And I think to some extent, as a culture, we have begun to see some of that come to light already in terms of how people treat information on the internet. Okay, I mean, when things started out, it was like anything you read on the internet was absolute fact. And now, as a culture, we're beginning to recognize, okay, that's not true. A lot of the misinformation that is out there has actually caused a lot of issues. So in the same way that they have sort of begun to recognize not everything they read is fact and they have to have methodologies to verify that, how do we take that sort of recognition and broaden it out into data? Because, I mean, basically a lot of the information we're talking about in the internet is data. So how do we broaden that out as this is what happens to data itself? That if you do not have methodologies and people and processes for verifying this information, you are going to be subject to the same issues, that you're going to get bad results and you're going to get bad information because it's not well handled.
Well, you know that that the 2022 word of the year is gaslighting. And we, I hope everybody on the planet understands that most sales pitches are gaslighting, right? Intentionally gaslighting, and that's a cooperative relationship that we have because they talk about possibilities. I think students, young people learn by experience. This demonstration, they are going to have to take a data objects for themselves and put it here, but we need to devise these intentional mechanisms whereby they can see for themselves what's happening to that data as they move it between technology. And that needs to be done at the learning stage. It needs to be done while they're young, and it requires some critical thinking. Tragically, in today's learning systems, we don't teach people critical thinking anymore. That's why so many people fall for the gaslighting they see on the internet. It's why people fall for the sales pitches. It's why people buy technology instead, because we have not focused on that critical thinking. And for data management, critical thinking is essential. We have to teach people how to think about their data critically and to understand exactly what's going to happen to it so that when we put data and technology together, what we do is on purpose and not by accident.
Fantastic conversation. So today's message, mind the data. Don't damage your information going forward. I love our messaging and where we're going with trying to educate folks, not only our current professionals, but the students coming up who will be joining our own industry and many other energy industries across the next decades. I really want to thank you, Trudy, and our three wise guys for joining us today to really think about the shifts in our industry and the shift in the PPDM Association to focus more broadly across energy industries to better steward the data that we're going to rely on to make decisions to be successful in the next coming decades, years, centuries. I welcome everyone who is listening today to look ahead for the next podcast. We will be inviting another series of presenters to join us and talk about all sorts of things related to the challenges and discoveries that await us in our industry, and to address the challenges so that someday we can all sit on a beach and not worry about our data, knowing it's in good hands. So thank you all and have a wonderful holiday season.
Thank you, Barb.
Take care.
Thanks, Trudy.
Thanks, everybody. It was a great pleasure.